So here's a linear second order constant coefficient non-homogeneous differential equation. And we've got initial conditions, so we need to find the constants. So the first thing we're going to do then is, well, because it's non-homogeneous, step one is to find the homogeneous solution. And that means auxiliary equation. So prime prime lambda squared 1 prime 1 lambda no prime no lambda equals 0. This is me solving the homogeneous system. So I've written down the auxiliary equation. Solve for lambda, and I've got complex conjugate eigenvalues. Real part -2, complex part 2. So with that, we can write down the homogeneous solution. So the homogeneous solution is going to be C1, those are the constants that I'm finding with my initial conditions, e to the real part t, you have to put a t on top of that e part as well, cos imaginary part t plus next constant, C2, e to the real part t, there has to be a t on that one too, sine imaginary part t. So the real part of the eigenvalue goes on top of the exponential with a t. The imaginary part of the eigenvalue goes inside the trig with a t. We can see that because the imaginary part of the eigenvalue is 2, the period of oscillation for this, or sometimes people call it the quasi-period, the period of oscillation for the homogeneous solution is 2 pi divided by 2 pi. And because the real part is negative, the homogeneous part oscillates and eventually dies down to nothing, no matter what the c's are. Okay, we've got the homogeneous solution. Our next step then is going to be get the particular solution. So I need to make a good guess. I'm using unknown coefficients here. So I see that the target function is a line, 16t. So I'm going to put in the most general line, at plus b. So I need its derivative, which is a, and I need its second derivative, which is 0. All three of these pieces are going to go in the left-hand side, and I'm going to set it equal to 16t. So there's y prime prime plus 4y prime plus 8y equals the 16t. And here I need to now solve for a and b. Well, the coefficient that has a t in front is going to be 8at is got to equal that 16t on the other side. That's the t coefficient. So right away, a has got to be equal to 2. The constant coefficients, this 4a and the 8b, so 4a plus 8b, have to equal 0 because it's like there's a plus 0 there. I already know that a is equal to 2, so 4 times a, 4 times 2, that's an 8. So that means that, 8 plus 8b has to be 0, b has to be -1. So now we know our particular solution. Our particular solution has to be equal to 2t minus 1. Now we can check this. If I take this 2t minus 1 and differentiate it again, sub it in the left-hand side of the equation, it will equal 16t. It's a particular solution. So now our general solution is going to be equal to the sum of the homogeneous solution plus the particular solution. So now all that's left to do, so there's our particular solution. All it's left to do is figure out the c's. And it's at this stage that we figure out the c's. Don't figure out the c's in just the homogeneous solution. You have to wait till the end and figure out the c's with the general solution. All right, the first condition is it goes through the origin. So that means y equals 0 when t is equal to 0. Now e to the 0 is 1, cos of 0 is 1, e to the 0 is 1, sine of 0 is 0. So this is just going to be 0 equals c1 times 1 plus 0 plus 0, again, when I sub in t equal to 0, minus 1. So that tells me that C1 must be equal to 1. C1 minus 1 equals 0. So C1 equals 1. Now, for the second condition, I need this derivative. So I'm going to take this function and I'm going to differentiate it. So y prime general. Yeah, okay, I got to do some product rule here. To make my life a little bit easier, because I'm going to have to do product rule here, and I'm going to have to do product rule here, I'm going to write the general solution a little bit differently. I'm going to factor out the exponential. Across this bracket, I'm going to factor out this exponential just so I only have to do product rule once, because now it's a function times this bracketed function. And I also know that C1 is equal to 1, so I'm going to replace that. So now let's differentiate. All right, derivative of the first, minus 2, leave the second alone, plus, leave the e to the minus 2 alone. Now I'm differentiating the inside of the bracket. Cos becomes minus sine, and the 2 comes out from this 2 from the product rule. Here, the 2 comes out, not the product rule, the chain rule. And the derivative of sine is cosine. Okay, so there's the product rule derivative of here, and the derivative of this 2t minus 1 is just 2. So now there's our derivative, our slope formula, and it also, when I make t equal to 0, has a slope of 0. So 0 equals, now I'm subbing 0 in this whole piece here. E to the zeros are 1, so I'm just making them equal to 1. Sine of zeros are zeros, so they're gone. Cos of zeros are 1. And so this is minus 2. Oh, this minus 2 and this plus 2 cancel out. So I'm left with 2c2 equals 0. So c2 must be equal to 0. Okay, so now I can take I had my general solution. I know that c1 equals 1. And I know that c2 equals 0, so this whole piece is disappearing. And this is the solution to that differential equation with the conditions y not equals 0 and y prime not equals 0, using unknown coefficients.